Okay, in problem 21.9 we have an amusement park ride, which is a rotating cylinder. We have people standing around the outside edge, and once the amusement park ride is spun up, the floor drops out and the person sticks to the side. They give you information like the diameter of the amusement park ride, the mass of the people, maximum, the area of contact with the wall up here, as well as the coefficient of friction mu, which is 0.7, a unitless term. It turns out that this is not really needed. These two things are not really needed for the solution of the problem, so you might note that at the beginning. To solve this problem, you set up a free body diagram for the person standing against the wall. The free body diagram looks like this, and what will happen is you have friction from the wall acting up, you have gravity acting down, and then you have a normal force acting inward toward the center. That's your centripetal force. So you have the diagram with friction up, gravity down, normal force toward the center. If you sum the forces in the x direction only, you get that the normal force is directed to the left, so you have a minus sign, and then the centripetal acceleration is directed toward the center, so you have a minus v squared over r for the centripetal acceleration. So because this person is turning, therefore you have an acceleration which is v squared over r in the x direction. In the y direction, if you sum the forces in that direction, that's up and down over here, you find out that you have a friction force up and gravity down, as shown in this diagram right here. That's equal to 0 because there is no acceleration up and down for the geometry of the problem we have selected. Another thing that you will need besides those two equations is the fact that the frictional force is equal to the coefficient of friction times the normal force. Then what you can do is solve for Fn in terms of these variables and put it over here. Solve for the frictional force and put it over here. You find that it's equal to the force of gravity, which is just mg. And so it looks like the m's will cancel out. And then you can also use either v is equal to r omega or v is equal to 2 pi r over p to solve for the period and to solve for the angular velocity. So the rest of this is algebra once you get to this step.